Okay, so today we went over an MCAS question, and it has to do with midpoints and a bunch of other things. So we're going to go through it and make sure you know how to do every part of it. So here we have the question. Triangle MNP has vertices at M00, N20, P1216, and we are going to let point R be the midpoint of MN. So this is point R right here. It's the midpoint of MN. And then we have S as the midpoint of NP. So we have S as the midpoint of NP. Okay, so what is the question asking us? What are the coordinates of each point below? All right, what are the points they're asking us about? Let's see. They want us to find the points R and S. Okay, so there's two ways we can figure this out. So basically, we can count. The first way is we can count because PN, right here, PN, is parallel to the y-axis. When a line is parallel to the y-axis, we know that we can count. So therefore, if we're just going to count, we know that the midpoint of NP, which is S right here, would be 12, 8. We can also count for R because MN, right down here, MN, is parallel to the x-axis. And we can just count boxes if a line is parallel to the x-axis. So therefore, the midpoint of MN, which is point R, would be 6, 0. Now, let's say you're not totally comfortable with doing it that way. That's fine. We can do midpoint formula. So I'm going to erase this right here, and we'll do the midpoint formula to find out what R is and to find out what S is. So I'm just going to set up a little table here so I can work organized. I'm going to write out the formula first. All right, so let me plug in my values. I have X midpoint equals 12 plus 12 over 2. And then I have the Y midpoint equals 0 plus 16 over 2. I have X midpoint equals 24 divided by 2 is 12, comma, Y midpoint is 16 divided by 2 is 8. I'm going to write the final answer as a coordinate, which is the exact same answer that we got when we just counted. But if you want to do it this way, go right ahead. And then for S, we're going to find the coordinate of S. We're going to write out our formula again to start. All right. I'm going to plug in my numbers from the question. I am going to get 0 plus 12 divided by 2. And then the Y midpoint is going to be 0 plus 0 divided by 2. So my X midpoint, 12 divided by 2 is 6. And then my Y midpoint, 0 divided by 2 is 0. And I'm going to get 6, 0 as the point S, which we got before when we counted, but whichever way you want to do it is totally fine. Actually, let me just write these in before these go away. Okay. I have S equals 6, 0, and then R is 12, 8. Okay, so now we have everything written down. All right, so what is the question asking us next? Is RS parallel to MP? All right, let's see. Well, what do we know about parallel lines? We know that parallel lines have the same slope, right? So all we need to do is calculate the slope of line RS and line MP and see if they equal one another. If the two slopes are equal to one another, we know that the lines are parallel. So let's calculate the slopes. Again, I'm going to make like a little table just to organize my work. So I'm going to do the slope of RS, and then the slope of MP. All right, so what is slope formula? M, or slope, equals y2 minus y1 over x2 minus x1. Okay, so R is 12.8. S is 6.0. And then MP, we have M is 0.0. P is 12.16. Okay, so now we're all set up and ready to work. Let's find the slope of RS first. So we're going to have y2, which is 0, minus y1. So I'm going to have 0 minus 8 over x2 minus x1, which is 6 minus 12. And then I'm going to get the slope equals negative 8 divided by negative 6 is going to give me 4/3. That's the slope for RS. Now let's find the slope of MP. Remember, we have y2, which is 16, minus y1. 16 minus 0. Sorry, let's do that in blue just so you can see where I got it. 16 minus 0, all over x2 minus x1, which is 12 minus 0. This reduces to 16 over 12, which reduces to 8 over 6, which reduces to 4/3. So both of our slopes are equal. Therefore, RS is parallel to MP. All right, so we answered that part of the question. The next part of the question asks us, what is the length in units of each segment? All right, well, there's two ways to do this. We can either count Pn because it is parallel to the y-axis, so we can just count the number of units. So it starts at 0 and goes up to 16, so Np equals 16. We can count the number of units for Mn because Mn is parallel to the x-axis. Mn equals, let's see, it goes from 0 to 12, so 12 units. And then now we just need to find the third side. Distance of MP. So this is for MP. Distance equals the square root x2 minus x1 squared plus y2 minus y1 squared, right? So we're doing MP, so let's just write our things over here. We have M, 0, 0, then P, which is 12, 16. This will be our x1, y1, x2, y2, we have distance equals the square root. x2 is going to be 12 minus x1, which is 0, squared, plus y2 is 16 minus 0 squared. Shoot. Oh no. Dropped my thing there. All right. So when we add them together, we get distance equals the square root of 400. And the square root of 400 is 20. So for this, we have 20. NP is 16. MN is 12. You could do the distance formula to find these two if you're not totally confident in the counting method, but I am not going to find it because you should be confident in it by now. Okay? All right, so that is the final answer for part D. Okay, so that's it. We're done.